Okay, let's now talk a little bit about Inter-VLAN routing, and it works with both routing and switching. We need it in order for our switches and our routers to function optimally with different settings that we have set up. So some of the things that we're going to look at in this unit include Inter-VLAN routing configuration, how to troubleshoot the Inter-VLAN routing, how it works with layer 3 switching, and then we'll summarize things. So our objectives are going to be to describe the three primary options for enabling Inter-VLAN routing. You need to configure legacy Inter-VLAN routing because you may have legacy equipment, configure router on a stick Inter-VLAN routing, troubleshoot some of the common Inter-VLAN configuration issues, troubleshoot common IP addressing issues in an Inter-VLAN routed environment. We're going to configure Inter-VLAN routing using layer 3 switching. Currently we've looked at things using layer 2 switching, and troubleshoot Inter-VLAN routing in a layer 3 switched environment. So let's look and see what Inter-VLAN routing is. It is a layer 2 switches. They cannot forward between VLANs. Remember, we've already set up several different VLANs, and this keeps our packets separate. Well, what happens if you need to send information from one segment of your network to the other if they're on separate VLANs? Your layer 2 switches do not allow this. Inter-VLAN routing is a process for forwarding network traffic from one VLAN to another using your router. So let's look at the legacy Inter-VLAN routing. In the past, our actual routers were used to route between VLANs, and each VLAN was connected to a different physical router interface. The packets would arrive on the router through one interface. It would be routed and leave through another interface. And since the router interfaces were connected to VLANs and had IP addresses from that specific VLAN, routing between VLANs was archived. Simple solution, but it was not scalable. Large networks with large number of VLANs would require lots of router interfaces, and this can be very expensive. Now let's look at router on a stick. The so-called router on the stick approach uses different paths to route between VLANs. One of the router's physical interface is configured as an 802.1q trunk port, and now that interface can understand VLAN tags. Logical sub-interfaces are then created, and one sub-interface per VLAN. So one interface can have multiple sub-interfaces. Each sub-interface is configured with an IP address from the VLAN it represents, and the VLAN member or the host are configured to use the sub-interface address as a default gateway, and only one of the router's physical interfaces are used. So that way we're using less resources. With multi-layer switches, you can perform layer 2 and layer 3 functions. Routers are not required anymore, and each VLAN existent in the switch is an SVI. The SVI are seen as layer 3 interfaces, and the switch understands network layer PDUs, and therefore it can route its SVIs just as a router routes between its interfaces. So the layer 3 switch is taking on some of the roles of a router. With a multi-layer switch, traffic is routed internal to the switch device, and it's very scalable solution. Think scalable, think saving money. Some of the preparations we need to take into account. We have legacy. Inter-VLAN routing requires routers to have multiple physical interfaces. Each one of the router's physical interfaces is connected to a unique VLAN. Each interface is also configured with an IP address for the subnet associated with the particular VLAN, and the network devices use the router as a gateway to access the devices connected to other VLANs. Okay, so here we go. We have our switch, and on our switch we have VLAN 10 and we have VLAN 30, and then we have this router sitting here where we're going to have a router on the stick. This is where we're going to be able to tell them where everything is being transferred. Here's our switch configuration. First we configure our switch, and this is with legacy Inter-VLAN routing. We set up our VLAN 10. We set up VLAN 30s. We give them their interfaces. We give them switch port access for each interface that we want to allow on that particular VLAN. Then with the legacy, we're going to go in on the router, and here you'll see that interface G000 is given an IP address, the same for the interface G01. So they each have a separate interface IP address that goes with that particular VLAN. The way we can distinguish the VLANs here with the addressing scheme, we know that the 172.17.10 is with VLAN 10 and 172.17.30 is with VLAN 30. So we've used up two interfaces in order for these VLANs to communicate. Now, with router on a stick, we can go about it a little bit differently. It is an alternative to legacy Inter-VLAN routing, and it's used the VLAN trunking and sub interfaces. With VLAN trunking, it allows a single physical router interface, so we only have to use up one of our router's interfaces to route traffic from multiple VLANs. The physical interface of the router must be connected to a trunk link on the adjacent switch, so you have to have your trunk port set up on your switch. And on the router, the sub interfaces are created for each unique VLAN on the network. Each sub interface is assigned an IP address specific to its subnet VLAN and is also configured to tag frames for that VLAN. So here you see we have a switch that has two VLANs on it. We have our router, and here on this switch, besides we have F011 going to VLAN 10, and we have F06 for this particular one going to VLAN 30, we've set up the Ethernet port F05 as a trunking port. And then with our routers, we will have sub interfaces. So the first thing that we're going to do is we will set up our VLANs. And you see that VLAN 10, we have VLAN 30 have been established. Then we say interface F05, which is this one. We've put it into what's called switch port mode trunk. So we've put it in trunking mode. Next, we'll go over to our router. And this time we're only going to work with one interface. But you'll notice that we say interface G0/0.10. That's our VLAN, that is our sub interface. We give it encapsulation DOT1Q10. We assign it its IP address. Then we assign the .30. You have to encapsulate it with .1Q30, and you give it its IP address. And then you make sure that you bring up or do the no shutdown for the interface. Not the interface with its sub interface listed, but the interface itself. If you do not do this step here, the interface G00, no shutdown, then your VLAN still will not communicate because that interface is not up. You can verify your sub interfaces by doing show VLANs, and you'll see here that it says that VLAN trunk interface. VLAN trunk interface, so we know that we have our sub interfaces set up correctly. You can also do show IP route, and you'll notice here you have your sub interfaces listed. To verify routing for router on the stick, you access to the device on the remote VLANs can be tested using the ping command. The ping command sends an ICMP echo request to the destination address, and when a host receives an ICMP echo request, it's going to respond back with the ICMP echo reply. Tracert is useful utility for configuring the routed path taken between these two devices.